Now we're going to take a look at the flowing material balance analysis. The flowing material balance analysis is probably the single most practical and popular feature of the RTA software. And we've been using this tool for years in a variety of different producing environments with great success. And one of the reasons why it's such a nice practical and useful tool is it's very easy to apply this technique. All it really is a straight line analysis of some production data. And we can do this on oil wells or gas wells. In this gas well example, we're of course extrapolating to a gas in place volume. Now the purpose of the flowing material balance is, just like the name implies, is to provide an in-place fluid. It's just like a conventional static material balance analysis. The only difference is that all of the underlying data is based on the flowing condition rather than shut-in data, which obviously for operators provides a huge practical advantage. We don't have to shut in our well in order to obtain this data, but it provides us the same level of information or the same type of results that we would get from a conventional shut-in P over Z data point or static material balance analysis. So huge practical advantage because we're collecting this data every day as a part of good production practice. It's flowing rate and pressure data. To confirm this analysis, we can also turn on the static P over Z plot. This is the equivalent static material balance analysis. That is the one data point that we have. And it's useful to compare these two to make sure that they're consistent. The flowing material balance and the static material balance will always be consistent with each other if the productivity index of the well is relatively constant through the life of production. And we can show that plot on here as well. This is the productivity index of the well, and we can see it is relatively flat. This offers another useful place to do well diagnostics. If this productivity index happens to drop off through time, that's an indication that there's something happening in the well. Either we're accumulating damaged skin or possibly loading up with liquids in a gas well. That's something that's not obvious or not immediately obvious if all you're looking at is the production rate. We need to look at the rates and the pressures together to really learn what's going on. One other thing to indicate in the flowing material balance analysis is the presence of this pseudo time. The pseudo time is causing this data to have this dynamic behavior. This occurs anytime we're analyzing gas data. With gas production data, the gas properties are dynamic with pressure. So anytime we're changing the positions of the lines, all the data points have to be recalculated on the fly. And luckily the software can do that pretty quickly. If we were to do it by hand, obviously it would require extensive calculations and reiterations of the data. But RTA is doing all of these calculations dynamically and on the fly. This doesn't happen with oil. Oil is a single phase fluid, so everything remains static when we're doing this calculation with oil. All right, so let's move on now